All right, guys, so please take out, I'm not going to talk about the quiz today because I am gone tomorrow for a training. I'm here after school, but I'm not here before school or for class, okay? So what's going to happen is I'm going to teach today. Tomorrow you're going to work. One of the things you can work on, thank you. One of the things you can work on is making quiz corrections and talk to your peers, guys. I taught these lessons and there's people in here who learned and did well on the quiz on different sections. So talk to different people about how they understood and did well on the different sections, okay? Then you can also be finishing up the homework check that's due tomorrow. And you can be working on the stuff that goes with the lesson I'm teaching today. Does that sound like enough to keep you busy tomorrow? Okay. There's also, before I forget, there is a packet in the back of SAT practice. It's practice for the part that's math with calculator, okay? If you want to pick that up. All right. Are we good? Yes. 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 Just attach it to the homework check tomorrow, okay? Thank you. All right, guys. I just want to practice a little bit because this is really important, using the unit circle. So I'm going to do 3 minutes of this and then we're going to go on to today's lesson. Are we ready? Using the unit circle. First of all, what quadrant is negative 330 land you in? Okay, negative 330 lands you in the first quadrant. Once you know that, and you know where you are in the first quadrant, the fact that this is negative does nothing. Okay, so 330 negative direction lands you right here. Whoa, sorry. Okay, so you're looking at this ordered pair. What's the cosine? It goes cosine, sine, right? So the x value is the cosine. You write square root of 3 over 2, you're done. Okay, cosecant at negative pi over 2. Where is negative pi over 2? Or what's the ordered pair at negative pi over 2? Which is ordered pair 0, negative 1. Camden. Okay, guys, cosecant is not x over y or y over x. It's the reciprocal of what? 1 over the sine. What was the sine right here? So 1 over negative 1 is? Somehow you guys made these so hard. Cotangent 210. 210 is right here, so the ordered pair is here. Cotangent, it even says on your worksheet, on your reference sheet, if you look on the other side, it says cotangent is cosine over sine or x over y. Do you remember what I said about the denominators? Yeah, they always cancel out. So it's just negative square root of 3 over negative 1, cosine over sine, which is square root of 3. Okay? You don't have these questions, so these are just practice up here, guys. The sine at 0. Go over here. What's the sine value? 0. A few more. Please be paying attention. What quadrant are we in? Cosecant of negative 240. Okay, 240 is all the way around plus another 60. So halfway around plus another 60. Going in the negative direction would land us right here. Cosecant is the reciprocal of which number? It's 1 over sine, so it's the reciprocal of this. Reciprocal just means flip it over, guys. Don't go crazy. How does that rationalize? That's it. Sine of 210. Taisir, what's the sine of 210? Okay, that's the right ordered pair. Which one is the sine? The first number in the ordered pair is the cosine. The second number in the ordered pair is the sine. Yep. Cotangent at 0. Jared, you got that one? Be careful. Cotangent is what over what? Yeah, so it's 1 over 0 is undefined. Cotangent at pi over 4. Okay, some of you went crazy. Pi over 4. You started writing out square root of 2 over 2 divided by square root of 2 over 2 equals square root of 2 over 2 times 2 over square root of 2. It's just the same thing over itself, which is 1, right? Okay. Cosecant 315, last problem. 315 right here. Cosecant is the reciprocal of which one? Sine, so I got to flip that over. It's negative. It's kind of ugly. 2 square roots of 2 over 2. What happens then? Yeah, these cancel out, so we get negative square root of 2. Better? A little bit? I know the ones on the quiz you had to do like subtract 360 4 times or add 2 pi or some crazy business, okay? Cotangent is cosine over sine. So you take this number and you put it over this number. So if it was here, you'd have 1 over square root of 3. If it was here, you'd have 1. If it was here, you'd have square root of 3 over 1. Good question. All right, guys, this is worksheet. I'm going to talk about, what is it, 18 and 19? Okay, we're going to do a whole bunch of flipping back and forth. So it's not good if they're stapled together. Just have out 18 and 19 next to each other. Okay. We talked briefly about tangent in the past as the slope. Do you remember when we did this? The slope here is 0. It started to get steeper and steeper and steeper, and then it got really steep, so the slope was doing this. When we got to here, the slope of a vertical line is undefined. We got over here, and the slope became what? Those slopes are all negative. And the tangent was looking like this. Okay? I want to talk just a little bit about a couple other things here. This is kind of interesting way to think about it. They say if you were to graph the cosine graph, tangent is sine over cosine. So everywhere that cosine hits 0, you'd have a 0 in the denominator, which means it'd be what? Undefined. So there would be an asymptote everywhere that cosine was at 0. On the other hand, if you graph the sine graph, everywhere that it hit 0, what would happen? It'd be 0. So everywhere that the sine graph here, this one, is 0, the tangent is also 0. Just another way to kind of help you understand why it's doing what it's doing at different points. All right. Does anybody remember what the period was for tangent? Yes. If I just talk about this real quick, this quadrant is positive, positive. This quadrant is negative, negative, right? If I put all the y over x's in this quadrant, I get a positive. If I put all the y over, this is negative, positive. Just kidding. If I put all the y's over x's here, I get a negative value, right? That covers everything. When I get down here, they're repeating because a negative over a negative is a positive. So these two quadrants take care of all the tangent values, which is just 0 to pi. Now it's kind of weird because it's this branch and this branch. The next time it hits 0 is at pi. So this asymptote is at pi over 2. There would also be one at negative pi over 2. What about the next one over here? Yep. When you graph these with asymptotes, if you label at least 2 asymptotes and 2 ordered pairs, I'll call it a day. All right? Deal? So there's 3 asymptotes labeled. 1 ordered pair was at pi 0. What's another super easy one? All done. If we wanted to talk about a point on here, which I'm okay with us not, but picture in your mind for a minute, at pi over 4, picture the unit circle. What is the ordered pair at pi over 4? The ordered pair. Square root 2 over 2, square root 2 over 2, right? So what would the tangent be there? 1. So at pi over 4, you'd have a value of 1. I'm going to talk about that point a couple times today because when we stretch, we can tell the stretch pretty easily there. But I'm not going to talk about stretches very much on these. Even or odd? Does it have y-axis symmetry? Can I fold it over on the y? Is it the same upside down? Okay, let me draw this. And then take my handy dandy. Is it the same upside down? If it was going through the origin? Yeah. Yes. It is odd symmetry, has origin. It's an odd function, it has origin symmetry. All right. If you look real quick at the top of 19A, I believe on the far right corner, it talks about some properties of tangent. First of all, guys, the asymptotes aren't actually part of the graph. They're boundaries. I would like you to draw them and label them, but the actual graph for tangent is just these pieces. The domain is all real numbers except, look at that, the odd multiples of pi over 2. That means those asymptotes are at 1 pi over 2, 3 pi over 2, 5 pi over 2, negative 1 pi over 2. That kind of makes sense? I'm not going to ask you what the domain is, but does it make sense where they came up with that? Why is the range negative infinity to infinity? Got arrows, right? Tangent can be, remember, tangent is the ratio of a leg to a leg, so it can be really big or really small. It's an odd function, and this is the big thing we got to remember is that the period is pi, not 2 pi. All right, I'm going to go back here. It says the period is pi, so any change in period will be tangent pi divided by b. But look here, guys. It says the term amplitude does not apply to tangent or cotangent because the heights of these are infinite. The definition of amplitude is max minus min divided by 2. There's no max or min, so there really is no amplitude. So what does A do? It still does something to the graph. Yes, A is simply a vertical stretch, which honestly, we'll talk about in a minute, makes very little difference to the graph, and I'm not going to make you worry about. We'll show you an example in a minute. All right, so just here I wrote the amplitude was undefined. Okay. Any questions about tangent? Right. At the bottom of 19A, honestly, the only thing I want you to, all this stuff down here is old. It's not typed correctly, so basically you could just ignore it all. Okay. This is the only thing I care about right here in the middle. If you are checking your graph on your calculator, you want to make sure you're in radian mode. And if you start out with a zoom trig, that will be a pretty good window. Usually, you know, if your graph shifted up 10, I think zoom trig only goes like 5 to negative 5. So you might have to look for it if it's been shifted a lot. But otherwise, zoom trig sets, I believe, negative 2 pi to positive 2 pi as your x values. All right, I know I'm all over the place, but can you look real quick at 18b, the top of 18b? I desperately need to retype this whole note for today. But remember, tangent has a period only of pi. So when it says the new period for any trig function with a different b value is the normal period divided by the b, we have to be careful when it's tangent because normal is not 2 pi. All right, so if I backed up and talked about a sine graph, the normal period is 2 pi. So this one will have a b value of 3. So the new period is what? What about cosine? Normal is 2 pi. Here b is 5. So we'd have 2 pi over 5 would be the new period. What happens when we talk about tangent though? Normal is just pi. So if b is 3, the new period is... Now, students struggle with this because if this is the tangent graph, this is not pi over 3. Because remember, it was from here to here, and then we needed this piece before it got back to the 0. That's pi over 3. That undefined place is actually what? Halfway to pi over 3, anybody? Half of pi over 3 is pi over 6. So it's actually got pi over 6 this way, and if you wanted to, the other asymptote over here is at negative pi over 6. You could do that, or you could draw this piece to here. All right, what about the last one? Normal is pi for a tangent. If b is 4, the period is pi over 4. I started to write 2 pi, which it's not. Pi over 4. Okay, rather than graph a sketch right there, we're going to do one that has a 4 in it. This is on the bottom of 19A. It's handwritten, so it's kind of hard to see. I think it's on the left-hand corner at the bottom of 19A. Am I on the right page? Okay. I know you just want to smack me right now because they're just here, there, and everywhere. All right. This is a b value. So it changes the period. The new period will be what? Because it's tangent. Pi over 4. What else is going on, though? Okay, it is reflected. Now, the normal shape is this. Whoa, kind of. And so the new shape would be what? Yeah, it's reflected across the x, so it's going to go that way. Everybody all right? So we could draw it. It's going to go that way. We need 2 ordered pairs and 2 asymptotes. The period, if I say it at 0, it was at 0. When is the next time it's back at 0? Yes, pi over 4, 0. Because this branch and this branch constitute one period. Now, if you don't have to draw it that way, you could go this way, I don't care. But what's this ordered pair, or this asymptote halfway to pi over 4? 1/2 of pi over 4 would be pi over 8. So where is there another one over here? Negative pi over 8. Could we be done? We did 2 asymptotes and 2 ordered pairs. Can anybody humor me and find the next one? Negative pi over 8, 1 pi over 8. Pi over 4 was in here, which is 2 pi over 8, right? So the next asymptote is actually at 3 pi over 8. It's the odd multiples on this one. Odd multiples of pi over 8. Mod. All right. Next one's weird. This is at the same spot on your paper. What things are going... First of all, we could rewrite this as -2 tangent of t minus 5, if you like it that way better. What is the 5 doing? Vertical shift down 5. So our midline is down here at y equals -5. All those spots right used to cross the origin are shifted down 5, or across the x-axis, sorry. What else? It is negative again. For some reason, it's going this way again, right? Yes, it has a vertical stretch. We can't say amplitude. We okay on that? Because it doesn't have a max or a min, but it has a vertical stretch of 2. Okay, I want to talk about that. This is what I did. Okay, on the calculator, just so you could see, I graphed -5 minus tan t. Then I graphed -5 minus 2 tan t. Then I graphed both -5 minus tan t and -5 minus 2 tan t. Do you see much difference? Do you see that there's a tiny bit straighter up and down on one of them? But that's it. The only place you would probably could figure out what's going on is if you went to pi over 4, it used to be stretched. Well, okay, it would go to 1, but it's flipped over to be -1, but its midline is -5, so it would have been -6 in here. Yeah. This one stretches it down twice as much, so it's at -7. I'm not asking you to do that. I'm not going to worry about the stretch, okay? I just want 2 ordered pairs, 2 asymptotes. Anybody come up with an ordered pair, even before I draw it? Yes, 0, -5, and it's going this way, right? What's the period? 5. It has no b in here other than 1, so the period is pi. So the next time it goes through the origin would be, or through the midline, be pi -5. Does that seem okay with everybody? So what's halfway? Where's the asymptote? Pi over 2 would work. -pi over 2, I heard somebody say. You know where the next one would be? What's after pi? 3 pi over 2. Good job, guys. Good enough? Now, I probably didn't stretch it very good. It would have been a little bit straighter, right? Especially this one looks a little flat. Oh my. Or it just looks bad all the way around. If Riley watches this, she'll just laugh at me. Okay. We're back on 18A. I know. It's like a puzzle today. Which worksheet should we look at? Okay. What? You can't put cosecant in your graph. And your calculator doesn't have a cosecant button. You could do 1 divided by cosecant is sine. Everybody okay? 1 divided by sine. All right. What happens? Let me talk you through this. Everywhere that this used to be 0, what's 1 divided by 0 going to be? Undefined. So there's going to be an asymptote here. Where else? There. Yes, any x-intercept is going to become an asymptote when we flip it over. Now, before I go too far and we have a big mess, can you give me some ordered pairs? Where did the original cosecant go through here? 0, 0, which isn't on the new graph, but let's keep going. What was this point right here? Pi over 2, 1, yes. Then it had an asymptote at pi. The next spot here would be 3 pi over 2, -1. So this is 2 pi. It had a period of 2 pi. I'm talking about the original sine graph there. Had a period of 2 pi, right? The new graph still has a period of 2 pi. What happens when you do the reciprocal of this value, the y value there? Reciprocal of 1 is 1. What is the reciprocal of 1/2, we'll say? 2. What is the reciprocal of 1/10? 10. So it goes up really high. On this side, it starts to go back down, so the 1/2 would be 2. Yep, it just takes this little hat and flips over and makes it a bowl. Okay, flips that little piece upside down. Yes, it goes, it has no maximums. What about over here? What's the reciprocal of this y value? Reciprocal of -1 is -1. Reciprocal of -1/2 would be -2. All those values that were really tiny and close to the x-axis are now really big and far away from the x-axis, because it's a reciprocal. So I think we're in pretty good shape. Do we have 2 ordered pairs and 2 asymptotes? I'm going to do a couple more just because it's our only, this is kind of our parent graph for cosecant. It would have a -π/2, -1. There'd be another asymptote out here at -π. There's an asymptote at x equals 0, x equals pi, x equals 2π, x equals 3π. Okay, again, the dotted sign graph and all the asymptotes are actually not part of the graph. They're just boundaries and helpful hints. The blue are the only ones that are actually part of the cosecant graph. All right, if you look back, I think I might have this wrong. Is it 19b? Maybe it is 19b. But make sure you're looking at the one that says cosecant. Like the second one up from the bottom of the page, right? The cosecant is here. They just did it nicely for us. But what I wanted you to see is that it has asymptotes at -π, 0, +π. So it's all real numbers except the multiples of pi. Is that crossed out on yours? Because I think it, did I fix it? Okay. The range is everything except -1 to 1. Okay, it has to be 1 or greater. If we wrote that in interval notation, we'd have some disgusting thing like, which you're not going to have to do, okay? It is an odd function because it's the same upside down and the period is 2π. Okay, because when I get to 2π over here, there's 2π. We had the up branch and the down branch. All right, we're going to do secant really fast because it's the same thing shifted over. So go back to this guy. Let's put a couple ordered pairs on here. 18, is this A or B? It is 18B? 18A. I knew I had one page misnumbered. Okay. 18A. Give me an ordered pair that's on this graph. 0, 1. What else? 2π and 1 is over here. That ordered pair up there. And so this minimum is at pi and -1. Okay. Do you remember how we did the other one? We took all the zeros and made them what? Okay, can you tell where those zeros were? We didn't label any of the zeros. What's halfway between pi and 2π? So we're counting by odd multiples of pi/2. Does that seem okay? -1 pi/2, +1, +3, +5. Okay. And then what do we do with all those little bumps? We flip them over. So it does have still an ordered pair at 0, 1. It's just now a relative minimum instead of a relative maximum. And here, it shouldn't be touching those asymptotes. I'm doing a crummy job of drawing it. It has a relative maximum at pi -1 and a relative minimum, etc. What's the period? Still 2 pi because it is still, it's just the reciprocal of cosine. Everybody okay? So this is kind of a little bit further towards the top on 19b. It just says this time the domain is all real numbers except the odd multiples of pi over 2. And it is an even function this time. Okay? And again, it's just these pieces that actually count. One more. Cotangent. All right. This actually kind of helps more if we look at the unit circle than anything. This would be 1, 0, 0, 1, -1, 0, and 0, -1. Are we okay? I was going around the unit circle. Okay. Cotangent is the reciprocal of tangent. Well, let's not even look at the unit circle. What's going to happen when we do the reciprocal of 0? It's going to be asymptote. Yeah, isn't that what we had on all these other graphs, guys? Everywhere that the original one crossed, it had an asymptote. Got a little confused there for a minute. Okay. The reciprocal of 0 is going to be undefined. Okay. If this is 0, what was the period for tangent? Because this is 1 over tangent. It was pi. So pi is right here. Okay, this asymptote is at pi. What's halfway in between there? Pi over 2. Okay, look over here. What's the cotangent at pi over 2? Cotangent is cosine over sine. It is 0. So where this used to have an asymptote, the tangent did, the cotangent now has a 0, which means it has a 0 here and here. Anybody know what those would be? 3 pi over 2, or this would be negative pi over 2. Okay. And let me talk you through this. Where this had really tiny little values, like 1/10, the reciprocal is now 10. Where it had a value like 1/2, the reciprocal is 2. Where it had a value like 2, the reciprocal is 1/2. Where it had a really negative number, like -10, it's now -1/10. You see why it switches direction like that? Because the reciprocal of big numbers are little numbers, the reciprocal of numbers close to 0 or 1 are close to 0 are still close. Close to 1 are still close to 1. The reciprocal of 1 is 1. I don't know what I'm even trying to say. Reciprocal of a number close to 0, like, it'd just be close to 1. Big numbers are small, small numbers are big. We're going with that. All right, so it's just a tangent graph reflected and shifted, yes? The period is still 5. All right, 19b, this is at the very bottom, I think. These are the cotangent ones here. It's kind of a mess, okay? The undefined places are pi, 2 pi, negative pi, 0 pi, so all the multiples of pi. Yep, and the zeros, if it asked where it had zeros, it would be pi over 2, 3 pi over 2, etc. Okay, easy ordered pairs. All right. We're going to start stretching these bad boys. We're only going to have time for a couple, so stay with me. Okay, y equals 2 secant 3x. What you want to do first is graph y equals to what? Cosine 3x. You can do it in dotted form, but what can you tell me about this graph? Amplitude of 2 and a period of, okay, cosine. All right, cosine starts at, yep. You don't have to draw as many periods as I did if you don't want to. So the maxes are all at 2 and the mins are at negative 2. What's the period? So where does that happen? Right there is the ordered pair 2 pi over 3, comma 2, right? And where's this min down here at? Halfway to 2 pi over 3 would be 1 pi over 3. Everybody okay? So this would also be a negative pi over 3, negative 2. You don't have to do that one if you don't want to. Okay. The asymptotes of the actual cosecant graph or secant graph will occur where? Yes, the zeros. So what's halfway to pi over 3? Okay, so there's pi over 6. Then there's another pi over 6 to pi over 3. The next time would be, yeah, 3 pi over 6s or pi over 2. 5 pi over 6s. Negative pi over 6. Anyway, got enough. Now, we struggled with this last period. They wanted to tell me that because the reciprocal of 2 is 1/2, that this should be down here at 1/2 when we flip it over. The issue is when you type this in, you would type in your calculator 2 because the amplitude change, that vertical stretch happens later, and then you would type 1 divided by the cosine of 3x. It has to do with the order things happen in. You reflect it and then you stretch it. So you reflect this maximum of 1 to 1 and then you stretch it up to 2. So guys, it does still just flip these around. I'm just trying to explain to you why it's not really the reciprocal of the max and min anymore. It does just flip them around. It has to do with the order things happen in. All you need to know is that those maxes and mins stay and become flipped over, okay? Do we have enough? Looks like enough to me on that graph, right? Okay, I know I don't have a lot of time. Do you want to pick one more? I'd like to do 2, but what do you want to try? I'm going to fly through this in 30 seconds. This number 1 on the back of 18b, this 3 just stretches it faster, so it really does nothing. But what does this do? What's the normal period for this? So pi divided by 4 pi becomes 1/4. So tangent looks like this, and it finishes the whole thing by 1/4. It's really tiny. Or it does a 1/4 this way and a 1/4 this way, which makes these asymptotes at what? Yes, 1/8. Negative 1/8. 0, 0, 1/4, 0. I'm done. Is that good enough? Okay. How about one with a shift, up or down? Can we try number 5 or 6? Want to do 6? Okay, I haven't done this one today. Shift down 1. We're going to graph cosine of 1/3 x minus 1. Okay, so the midline's at negative 1. What's the period? 2 pi divided by 1/3. 6 pi. And it's a cosine, right? Amplitude is 1. So it starts at its max, which would be here. Okay, and the period is 6 pi, so halfway there would be 3 pi, and the asymptotes I'm thinking then are halfway to that, which would be 3 pi over 2, yes? Halfway to 3 pi is where it's crossing this midline, right? And that's where the asymptotes go. What's between 3 and 6, guys? 3 and 6, half of that would be 4.5, which is 9/2. Yep. You don't have to label that one. You could have gone this way and gone with negative 3 pi over 2, right? Okay, now we just flip them. So there's an ordered pair where? 0, 0. I like that one. Over here, there's a minimum at, or it's now on relative maximum. 3 pi negative 2. Okay. I think that would be right. 15 pi over 2, maybe? All right. So what you need to do, guys, tomorrow, I'm not here. You are to work on page 276, 277, whatever it says. Quiz corrections and turn it in your homework check that's due tomorrow. Okay?